Hi, I'm Nico. In this video, I'm going to talk about what piezoelectricity and flexoelectric effect are and how they may be related to the cause of thunderstorm. First of all, what is piezoelectricity? Piezoelectricity is the phenomenon in which the mechanical stress or pressure applied to a material is converted into electricity. In other words, you can create electric potential by applying pressure to piezoelectric materials. One example of piezoelectric material is quartz, SiO2. Apparently, piezoelectricity arises when a non-central symmetric structure is strained uniformly. In simpler terms, the piezoelectric effect takes place in materials in which the positive and negative charges are unevenly distributed. When you apply a uniform force or pressure to the entire crystal, the ions consisting the material gets displaced uniformly. This makes the distribution of the positive and negative charges more uneven, resulting in an electric potential or voltage. Piezoelectricity is used in sensors like sonar equipment. Sound is propagated as change in water pressure, so sensing pressure is the same as sensing sound. When pressure is applied to the piezoelectric component of the sonar, there will be an electric potential in response to that, which can serve as the sonar's output signal. Let's move on to the next topic. What is flexoelectric effect? Flexoelectricity is a little similar to piezoelectricity. Flexoelectricity arises when any structure, central symmetric or not, is strained in a non-uniform way. Put simply, you can create an electric potential in any material by bending or twisting it. When you bend or twist a material, that leads to an uneven distribution of positive and negative charges in that material. That means some regions will be relatively positive and some regions will be relatively negative. This difference results in a voltage or electric potential. This electric potential is very small, so you probably won't actually see or feel flexoelectricity in action in your daily life. Now I'll talk about recent research on what causes thunderstorms. It is known that lightning forms when the electric potential accumulated in ice particles consisting the cloud is released. This accumulation of electric potential is thought to be caused by the collisions of the ice particles with each other. However, ice, frozen water, has a central symmetric structure and so it's not piezoelectric. That means applying uniform pressure to a bulk of ice does not produce any electric potential. So ice particles being compressed during collisions can't be creating the electric potential that causes thunderstorms. But flexoelectric effect, which can theoretically occur in any material, can still take place in ice. So you could create a small electric potential in ice if you manage to bend or twist it. In recent research, a team compared the electric potential generated by ice particle collisions in thunderstorm clouds with the electric potential generated by bending ice. Because the results matched, they concluded that flexoelectric effect could be playing a role in thunderstorms. In this scenario, when ice particles collide and deform, which means a non-uniform force has been applied, the flexoelectric effect occurs. This gives rise to an electric potential and causes a thunderstorm. When I read that article about this research, I was surprised to learn that we didn't actually know how thunderstorms work. By the way, I wonder if some materials create more electric potential than others from the same bend or twist applied. In other words, what determines the flexoelectricity of a material? The polarity of the bonds between the atoms consisting the materials, perhaps?